Hey guys, today we're going to review combinations and permutations. So a 6-letter permutation is selected at random from SIMPLE. Find the possible numbers of ways of each event. So there are 6 letters in simple. What if the second letter is P and the last letter is M? So there's only one option here and there's only one option here. Out of the 6 letters we have placed 2, leaving us with 4, then 3, then 2, then 1. And if I multiply 4 times 1 times 3 times 2 times 1 times 1, I get 24 ways to arrange the letters, given a P in spot 2 and an M in the last spot. Okay, again with the same letters. This time the second letter is a vowel and the third letter is a consonant. So the vowels, I and E, there are 2 of them. The other 4 are consonants. I have now placed 2 letters, leaving me with 4, and 3, 2, and 1. So when I multiply all of these numbers, I find that there are 192 ways to arrange these letters. Okay, this time, the second and third letters are both consonants. Okay, we found earlier there are 4 consonants to choose from. I have now placed 1 consonant. I'm going to place another, but there are only 3 options left because I've already placed 1. Okay, so now I have used 2 letters. I've got 4, 3, 2, and 1 remaining for a total of 288 ways to arrange those letters. Second letter is a consonant. The last letter is I. There are 4 consonants. I is not one of them. There's one I. I've placed 2 letters, leaving me with 4, 3, 2, and 1. And when I multiply those, I get that there are 96 ways to arrange the letters. The second letter is a consonant. The last letter is S. There's one S. There are 4 consonants, but S is one of them. So I no longer have S to choose from, which means I've only got 3 consonants to choose from. I've placed 2 letters, leaving me with 4, 3, 2, and 1. And I multiply those to find 72 ways to arrange the letters. Luke N. Sharp has 12 pairs of pants, 18 shirts, 3 belts, and 15 pairs of socks. How many different ways can Luke select a pair of pants and a shirt? So we're selecting 2 options, pants and a shirt. This is the called the basic counting principle. He's got 12 pairs of pants and 18 shirts, choosing 1 from each category, 216 ways. How many different ways can Luke select his daily ensemble? So he's got pants, shirts, belts, and socks, 12 pairs of pants, 18 shirts, 3 belts, and 15 pairs of socks, choosing 1 from each category. Multiply and find that there are 9,720 different ways to make this selection. A classroom is filled with 15 boys and 12 girls. How many different ways can we select a boy or a girl? Or means this is mutually exclusive. When it's mutually exclusive, we add. There are 15 ways to choose boys, 12 ways to choose girls. 15 plus 12 is a total of 27 ways to choose. How many different ways can we select a girl and a boy? Okay, just like selecting pants and a shirt, there are 12 ways to select a girl. There are 15 ways to select a boy. 12 times 15 is 180 ways to select one of each. So 27 ways to select one out of all of them, 180 ways to select one of each. In how many different ways can we select 2 boys and 3 girls? Okay, so selecting 2 boys, that is a combination of 2 boys out of the 15, and means I'm going to multiply my combinations of 3 girls out of the 12. I'm going to pause this and pull up a calculator. So I can evaluate this with the calculator. 15 math probability, option 3 NCR 2, so that gives me the number of ways to choose 2 boys out of the 15, times the number of ways to choose 3 girls out of the 12. $23,100 ways to choose 2 boys and 3 girls. How many different ways can we line up 5 students for a picture? Okay, so the same group of students, we're going to line up. Line up means order matters, which means you're going to use a permutation. Okay, so we are lining up 5 of these students, and there were 12 girls and 15 boys for a total of 27 students to choose from. 27, key, 5. Choosing 5 out of 27 for an arrangement. There are 9,687,600 ways to line up 5 of the 27 students. How many ways can the word rearrange be arranged? Okay, so there are repetitions in this word. So the word has 9 letters. So N is 9. 3 of those are the letter R. 2 of them are E, and 2 of them are A. So to find the number of ways we can arrange these letters, we do n factorial, 9 factorial over 3 factorial times 2 factorial times 2 factorial. And in my calculator, I have to put that denominator in parentheses, otherwise it will only divide the first ones and then it will multiply. And I don't want that. I want that multiplication to happen before I divide. So 9 factorial, math, probability, option 4, divided by 3 factorial times 2 factorial. And there's 2 of those. 2 factorial times 2 factorial is 2 factorial squared. 15,120 ways to rearrange those letters. How many ways can you arrange 8 people sitting around a table? Sitting around a table, that is circular. That is done by doing n minus 1 factorial. So that's 8 minus 1 factorial. 8 minus 1 is 7, so 7 factorial is 5,040 ways.